Hi everyone, in this video we will learn about the different storage protocols and what is a block storage and what is a file storage. So to keep it a bit simple, what's the difference between block storage and the file storage? So the block, in a block storage unit, the data is written into blocks of storage and each block has the same size, meaning that all of the blocks in the same storage unit has the same block size, like 4K 256. Okay, but this is out of our scope for now. Okay, and mainly the block storage unit, and we will learn in the coming slides what is a block, or in general, what is a storage unit. Okay, so a block storage unit is the storage entity that you provision on a SAN storage, for example, and then mount it or map it to your server. Okay, it's without a format, without a file system, and we will learn in the coming video about the file systems. So the server, I mean here the operating system running on top of that server, will be formatting the block storage with one of the supported file systems, and then the operating system will be able to read and write from the storage unit. Okay, when it comes to file storage, okay, so in that case, again, the block storage, the server who has the block unit mounted to it is the owner over that storage unit. Okay, when it comes to file storage or file shares, like the NFS protocol, SMB protocol, or FTP protocol, okay, in these scenarios, the owner here is not the client server, meaning that the owner of these volumes, of these shared file volumes, may be another server or a SAN storage or NAS storage that supports this protocol and has these volumes, storage volumes provisioned on it, and then being mounted to a client server or a client computer in general. So a client computer in this case will only be able to read and write, but it cannot control the local file system, or file system of this volume. But the file server itself, whether it's another server or the SAN storage or NAS storage, is the owner, and it could manage its own file system. Great. So what are the block storage protocols? And the protocols are the language, similar to language, that a server and a storage system use to speak to each other, okay, when it comes to storage languages. Okay, so the most popular block storage protocol is the fiber channel protocol, okay, and it's the most powerful and the most stable and the fastest protocol when it comes to transferring the data, and it's the main protocol used in production environments. And this leverages specific types of hardware. We will see it in the next slide, as well as using and transferring the data over fiber optic cables. Fiber channel OE stands for fiber channel over Ethernet. It's also a fiber channel protocol storage, but in this case it runs over the Ethernet, not over a dedicated storage fabric or storage cable. No, it shares the same fabric, the same network fabric with the Ethernet traffic. We will learn more about the hardware used for this in a coming slide. The iSCSI is also a block storage protocol, but it's not like fiber channel. It cannot have its own fiber channel, or sorry, it can't have its own physical media for transfer. So in most cases, or the main physical medium it uses is the Ethernet cables and the Ethernet switches. And it's considered less stable than fiber channel, and it doesn't have the high availability features that comes with fiber channel, like the multipathing. It supports multipathing. Indeed, we will have a look into what is multipathing in another lecture in this course, but again, it doesn't fail over from a faulty, let's call it a path. If you have a port 1 and port 2, you will see in the next slide, it doesn't fail over instantly from a port to another, or from path to another, and I will describe more in the upcoming slides. Okay, the final one for now, and it's considered the most recent fiber channel, or the most recent storage protocol. It's the NVMe. We have already learned about the NVMe technology in previous lectures. Okay, so FC NVMe, or NVMe over fiber channel. So it's a bit similar to FCOE, but it's not using Ethernet. So the NVMe packet, which uses NVMe commands or NVMe protocols, are running over fiber channel fabric or fiber channel optics for now. But again, so fiber channel uses SCSI commands, so fiber channel over Ethernet, and iSCSI. All of these protocols, or all of these block protocols, uses a command called SCSI command, and it's the protocol that reads and writes the data. It's called the SCSI protocol. But the NVMe has its own protocol called the NVMe protocol. All right, okay. Concerning the file storage protocols, we have the NFS, SMB, CIFS, and FTP. We may have other types of file storage protocols, or you may also, it's also called file shares, network shares, okay, shared volumes. And these types of protocols are controlled by a file server. It could be a traditional server that runs file sharing services, or a SAN or NAS storage appliance. And a file shared volume, or a file shared unit, it's mounted to client servers or client computers over the Ethernet, so it's not over fiber channel or any of those. It's transferred only over the Ethernet fabric, or the Ethernet medium, okay? And it could be accessed by multiple end users or end servers sharing the data in it, reading and writing. So each of these storage protocols or classifications are used for specific purposes. But you can't, and it's not preferred to store databases maybe on NFS. You should be hosting it on a block storage, not a file storage. Alright, so let's have a look on the used hardware for each protocol, and we will have a greater details on these components later in the storage fabric section of this course. Okay, so the first piece of hardware is the FCHBA, which stands for Fiber Channel Host Bus Adapter. So to use a fiber channel protocol storage, you would need a HBA card similar to that one. This is just a photo of one of the models. It could come with a single port, 2 or 4, like that one. Okay, it's a PCI card. And these modules, or these transceivers, are called SFP, okay, SFP or SFP plus, and it comes in different speeds. We will learn about the speeds in another section of this course. Okay, so these modules support plugging these connectors into it. So this is a fiber channel cable or a fiber optic cable. This cable could be used either for fiber channel storage traffic or also for Ethernet. But in this sample here, we are talking about storage. So this type of cables, it could come in different colors, okay, with this connector. So this connector is called LC, and this cable has the same connector on both sides. It's called LC-LC. So this cable is hooked to one of these ports here, and the other end is connected to a storage system maybe, or a storage switch. We will learn about storage switches and storage fabrics later in the course. All right, fiber channel over Ethernet or FCOE. So in this example here, when it comes to using this protocol, we will be using a piece of hardware that it's a bit similar to that one in the physical appearance. They both, you can't differentiate them unless you read the information here. So this card, actually, it's called CNA card. So it's not only a HBA card, now it's a converged network adapter. So this card here supports both fiber channel for storage and also Ethernet traffic. So this card actually has two virtual cards within it. It has a FC HBA card and a network Ethernet network adapter in a single physical adapter. So the operating system sees this card as two, okay, and you use a single cable that you hook it to one of these SFPs, and that single cable carries both traffics. The traffic of the fiber channel storage and also the Ethernet network traffic. And how could that be done, and how could we differentiate the incoming traffic? Well, on the other end of the cable, the server or this card, this adapter will be connected to a specific type of network switch that supports both kinds of traffic, the the fiber channel traffic and the Ethernet traffic. Okay, it supports both, so it segregates and aggregates the traffic inside the circuit board using the VLAN tagging. So the storage will have a VLAN tag, and the Ethernet will have, or other other Ethernet traffic. You may have VLAN or more VLANs for Ethernet coming and going through the same transceiver. And by the way, the speed of the transceiver may come with a 10 gigs of speed, 10 gigs, 25, 40, or 100 gigs gigabits per second of traffic per second. Okay, the traffic speed in this case is shared between the fiber channel traffic as well as the Ethernet. Okay, great. So let's have a look on the storage packet. Okay, so the application, so this is a bit similar to the OSI model, if you are aware of the OSI model. Okay, so this is the fiber channel frame. So the application sends or receives SCSI commands, which are the storage protocols to read and write data. Okay, and this SCSI command is encapsulated in a fiber channel protocol. So it's SCSI over fiber channel to form the FCP, the fiber channel protocol packets. Okay. If you are gonna send the traffic of the fiber channel over the Ethernet, like in FCOE, then it will be a fiber channel over IP in a packet like this. It will be the packet of the storage, the fiber channel protocol packet, will be encapsulated in an Ethernet in an IP packet, similar to this. So this is the fiber channel frame. This is the SCSI data. This is the data itself. Okay, so this is the frame that runs through the SAN fabrics. If you're using HBA cards, when you are leveraging fiber channel protocols only, which leverages a dedicated physical medium to transfer the storage data. Okay, but in case you're using fiber channel over Ethernet, so the entire fiber channel frame again will be encapsulated like this in a traditional Ethernet or IP packet to traverse the Ethernet traditional network and switches. Alright, so let's have a look on the storage units. What are the storage units? So we have the LAN and the shared volumes. So a LAN, it's the block storage unit. So when you provision block storage unit on your storage device, on your SAN storage system, it's called a LAN. It has a LAN ID. We will learn a bit about that in the storage fabric section coming soon in this course. Okay, and the LAN is mapped to your server or to multiple servers depending on the implementation. Also, the other type of storage units is the shared volumes, which is the file shared volumes like NFS, CIFS, so on and so forth. Okay, and on the end, on the other end of the server, on the other side of the cable, where you have your storage systems, okay, so you may have the same physical pool of storage. We will learn about the pools and aggregates later in this course, okay. You could carve the storage unit, the storage capacity you have to create multiple LANs and also more volumes to serve different purposes like block storage and file shares. That's it for this lecture. I hope it's been informative. In the coming lecture, we will be discussing the file systems, so stay tuned. Thank you.